when multiplying fractions, remember the rule is to multiply straight across. And so this becomes AC over BD. It is almost as if you could just, when multiplying, just connect those fraction bars. Just make it one big fraction. So to multiply polynomials, we're going to factor everything just like we did with simplifying. The top and bottom, multiply or just write as one fraction, and then cancel or divide all common factors. With division, there's an extra step. We're going to do everything here, but the first thing we're going to do is turn it into multiplication. So the first thing we're going to do is rewrite this as a multiplication problem, because when you divide, you are really just multiplying by the reciprocal. Those are the same things. And so this would be AD over BC. Notice how the division turns to multiplication and you flip the fraction. Do not sometimes, like, and so you're learning to multiply fractions, there's like shortcuts, or divide fractions rather, of like crossing down and stuff, or multiplying across, or cross multiply even, people say. Don't do those shortcuts. Rewrite the question, rewrite the whole thing, top and bottom, and then multiply. And so really quickly, division turns into multiplication problems. So here is one where there's not much factoring involved here. This is more like an exponent question. There's nothing to factor, but let's just practice our exponents and practice multiplying straight across. So if it's raised to the third, everything is raised to the third power. So that would be negative w cubed, and then y to the sixth, when it's up high multiply. And then let's just make this 3w squared y. And then square everything here, so that would be 4w squared y squared over 4w cubed. Okay, and now we're multiplying, so we go straight across. We could just think of this as one fraction if you want, and reduce wherever you can. And so these 4s will divide. And then you could reduce, or we can add exponents. And maybe the best thing to do is add exponents to avoid confusion. So let's just, on top, I have negative, and then add the exponents to get w to the fifth. And then I'm going to add the exponents to get y to the eighth. And on bottom, we have the 4 is gone, but we still have the 3. And then I'm going to add exponents to get w cubed. And then I'm putting little ones there, and then y to the fourth. And then now we can see this is negative w squared on top when we subtract. When you divide, you subtract exponents. And then y to the fourth on top. And on bottom, you're just left with 3. So it's negative w squared y to the fourth over 3. Okay, let's see some division here. And this is going to be quite a bit of factoring. That's okay. We like to factor, right? And with your division, notice that it could be written as this. It could be as a rational function divided by a rational function. So these are the same thing. First thing we're going to do with division is turn it into multiplication. So the first thing you think about division is get rid of division. And I'm going to rewrite the whole thing. A more efficient use of your space would be to factor as you go here. But I'm not even going to worry about that. So rewrite everything and just flip the top and bottom. Okay, and then let's do some factoring off to the side here. So let's do this first. 2x squared plus 7x minus 15. So two numbers that multiply to negative 30, 2 times negative 15, and add to 7 are 5 and 3, no, 15 and 1. I get, oh wait, hold on, I'm thinking of add to multiply to 15, multiply to 30. Let's try that again. Negative 10 and 3. So negative, or positive 10 rather, and negative 3. Okay, and then rewrite using those numbers. Oh, I don't need a line there. Sorry, just ignore that. Let's look at these two and these two. And I can take out an x. And that leaves me with 2x minus 3. And then here I can take out a 5 plus 5. So that is 2x minus 3. And so I did something right because I have a greatest common factor of 2x minus 3 and then x plus 5. So let's rewrite that here as 2x minus 3 and then x plus 5. Okay, now to factor this, we notice there is a greatest common factor of 4. And so let's take that out. Take out a 4 and you're left with x squared minus 25. And then you have a difference of squares. So you can factor that again. And let's just write that up here as x plus 5, x minus 5. Okay, so we have 2 factoring problems down and 2 more to go. Here, if I have 2 numbers that multiply to negative 10 and then add to negative 9, they're negative 10 and 1. And so let's rewrite this. And I can take out a 2 and then a 1. So if I take out a 2x rather, and then x minus 5, and then a plus 1, x minus 5. And that worked out because I have a new greatest common factor of x minus 5. And then the other thing that works out is you notice that something starts to cancel. Not that it has to, but it's a little bit like in math when you first start to learn to solve equations. If you got a decimal answer, you probably did something wrong, right? Even though the answers can be decimal, they're just written so it's not. Same thing, if you have a multiplication problem or division problem, it's likely that something is supposed to cancel. If nothing cancels, then maybe it's just simplified, or you did something wrong. And then this 4x squared minus 1, that's a difference of 2 squares. If I take this square root of 4x squared, I get 2x plus 1 and then 2x minus 1. Okay, and then we just want to reduce. So or divide or cancel. So 2x plus 1 and 2x plus 1. I have an x minus 5 over here and an x minus 5. And keep in mind we're thinking of this as just one fraction because it's multiplication. And then anything else. I have an x plus 5 and an x plus 5 I can get rid of. And that looks like it. So it looks like I'm left with a 2x minus 3 over 4 times 2x minus 1. That looks like all of it. And so this is fine. If you want to distribute, you can. And that's good too. You might, if it's multiple choice or something, you might have to recognize that these are the same. Excuse me. So how about checking your work for just a moment? So checking your work, you could go all the way back through and just, check all your factoring and everything. You could also plug in a number using a calculator. So like this whole thing, if you type this in your calculator with x is 2 and hit enter, and then type this as the calculator with x is 2, you should get the same number. You could also graph this. So if you graph this in y1 and graph this in y2, the graphs should look exactly the same because they are equivalent. This is a tedious thing to do, right? And so you probably don't want to check your work like that on a homework question, but it's a good way to check your work on a test or quiz, or if this were an ACT question, this is equivalent to this. One thing with your calculators is you're thinking about fractions. If you hit alpha and then y equals, you'll get a shortcut key that looks like n over d, and that will give you a little box and a bar and a box for your fractions. So that's worth doing. So alpha, y equals is the keys, and then find the n over d for numerator over denominator and hit enter. And that's very helpful for your fractions. Okay, I have one more we're going to look at. Pause the video and try this on your own. We got a lot of factoring, it looks like. And then let's just start factoring. So we'll do it kind of the same way we did before. We'll start with the top left here. And so I have 3x squared plus x minus 4. And I need two numbers that multiply to negative 12 and add to 1. And that's 4 and negative 3. So that'd be 3x squared plus 4x minus 3x minus 4. And we can just take out an x and a minus 1. And I'm going to do something dangerous here. I'm going to skip this flipping the fraction right now. So I don't think I could recommend this, but it's a way to maybe save just a little bit of space. And then, so now we're going to factor this, 2x squared plus 3x minus 5. So 2x squared plus 3x minus 5. And so that's two numbers that multiply to negative 10 and add to 3. So that's 5 and negative 2. So 2x squared plus 5x minus 2x minus 5. And take out an x, take out a negative 1, and that gives you, oops, there should be a 2 there, 2x plus 5 over x minus 1. Now be careful here. I'm going to turn it into multiplication, so I'm going to factor this guy first because he's moving to the top. And this follows a special pattern. It is a perfect square trinomial. And you can use the AC method if you don't see this. But if you take the square root of this and the square root of this, so that would be, we'll just kind of put that up here. That'd be 2 and then times 5. And then if you multiply it by 2, it matches to 20. 2 times 2 times 5 is 20. So that's a factoring pattern. And so if you notice that, then you can just take the square root, 2x in the square root of the first term, and the square root of the last term, 2x plus 5 and 2x plus 5. Or 2x plus 5 squared. You can use the AC method there, and you should get the same thing. I'm going to go ahead and write it out just to show, so it doesn't confuse you, or the exponent doesn't confuse you. And then we have one more to factor, which is the new bottom here, which is up here. And so that is 6x squared plus 23x plus 20. And so I need two numbers that multiply to 120 and add to 23. This might take me a minute here. Yeah, so as for some guessing and checking, those two numbers are 8 and 15. With big numbers like this, if you think it's not obvious, my advice is to just like go straight through. Just try 1, try 2, try 3, try 4, try 5, rather than bounce around, because you end up like guessing the same thing multiple times. Anyway, so that's plus 8x and plus 15. And then, oops, I forgot no, that's right, plus 20. And we can take out a 2x, it looks like, so that's 3x plus 4. Take out a 5, and that's 3x plus 4. And then, so this is 3x plus 4, and then 2x plus 5. So before you do anything, it would be a good idea to double check your order with the division. So make sure you flipped it. And so this 4x plus squared plus 25x plus 25 is up on top now, and this one is down on bottom. And now we can reduce. So here and here, those cancel or divide. This divides with this. This divides with this. And then does everything divide? It looks like they all divide. So this is just equal to 1. Okay, if you were to talk about domain, then you would have to find everywhere the bottom of the original problem is 0. So if you wanted to find domain for this, or the numbers you can't be, it's not go back to here, because this looks like everything's fine, right? If you go to the simplified one, but go back here, you have a problem with this fraction here. You have to find those numbers. You have or what this is. You have a problem with this fraction here, which is right here and here. So you would have a lot of values that you can't plug in for x for this problem. But it all simplifies down just to 1.